What does uranium enrichment actually mean? If you've ever wondered how a handful of atoms can decide the fate of the world, you're in the right place. Let's start simple. Picture uranium in its raw, natural form. It's mostly a heavy, stable isotope called U-238. But hiding in that mix is U-235, rare, powerful, and the real star when it comes to nuclear energy and nuclear weapons. Here's the kicker. Only about 0.7% of natural uranium is U-235. That's less than 1 out of every 100 uranium atoms. So, what is enrichment? It's the process of increasing the percentage of U-235 in a uranium sample. For nuclear reactors, I only need around 3 to 5% U-235. But for a bomb, you're talking close to 90%. That's why when you hear numbers like 3.67% or 60%, they matter a lot. Now here's the twist. Chemically, U-235 and U-238 are identical. You can't just separate them with a chemical reaction. Physics comes to the rescue. The only real difference? U-235 has 3 fewer neutrons than U-238. It's just a little lighter. And that tiny difference is enough for some clever engineering. Imagine a centrifuge spinning at insane speeds. Uranium is turned into a gas called uranium hexafluoride, UF6. In the spinning drum, the heavier U-238 is pushed to the outside, while the slightly lighter U-235 drifts toward the center. Iran, for example, uses IR-1 and IR-6 centrifuges. They spin so fast you need hundreds, even thousands, all working together in long cascades. This process is delicate, energy-hungry, and has to be repeated again and again to boost the U-235 percentage. Let's talk numbers. If a country enriches uranium to 60%, how close are they to bomb grade? According to experts, enriching to 60% gets you 80 to 90% of the way to weapon-grade uranium. In terms of technical effort and time, it's like running a marathon. The stretch from 0.7% to 60% is the hardest part. That final sprint from 60% to 90%? Much quicker. That's why 60% is a major red flag for international inspectors. All of this comes down to physics. Just 3 neutrons difference decides whether uranium is fit for a reactor or a bomb. On one path, we have nuclear power, lights on, cities running. On the other, the shadow of a mushroom cloud. The science behind uranium enrichment isn't just about atoms. It's about policy, security, and the future of global peace. 1 isotope, 2 paths. The choice may be political, but the physics? That's absolute. Like and comment if this helped you understand the science behind uranium enrichment.